Our next guest will have, let's just put it this way, we'll have two challenges. The first challenge will be to compete with the digestive process post-lunch. Okay, so hopefully he will, and I'm sure that he will manage to do that. And the second challenge will be to show us the basics of DDD, domain-driven design, and its practical implementation of self-contained system in a distributed landscape. And we'll see the benefit of domain-related system borders and the use of event-driven services, service buses like Apache Kafka. Ladies and gentlemen, please welcome Christian Schmidt, IT consultant and senior software engineer at Tarent Solutions. With more than 15 years, Christian consults and designs distributed systems based on domain focus view and asynchronous interconnections from requirements, the requirement phase, over the development and DevOps related purposes, as well as cloud native applications and cloud migrations project for both public and private clouds. That being said, Christian, you have the floor.
Okay, so hello everybody. I hope after lunch you're a little bit fit. So if you fell asleep, just hold your hand and I talk a little louder. So yeah. I have a topic with domain-driven design and self-contained systems to a better data architecture. It's a long title, so I abbreviate it a little bit. So, who we are, who am I? We are from Tarent, from Germany, partner of the E-Solutions. We have places in Bonn, Berlin, and Köln. Yeah, and who am I? I'm Christian Schmidt. Christian Schmidt is the German pendant to John Doe, so nobody finds me in the internet with Christian Schmidt. And also the slides are old. I'm now 37 years old. Yeah, 1st October. Yeah, and what do I do? I begin as a software developer, then software architect and IT consultant, so I'm not a big data or data engineer. I make the stuff before I produce data. I don't analyze it. But, yeah, and also I have a nice family there. Yeah, okay. Cool. Okay. What do we want to do today? I will show you how we can produce or how we can make a good system to produce data that your big data guys can use to analyze. So we have a good ground and good data ground. So first of all, who knows Conway's law? 1, 2, 3. Okay, cool. Conway's law, known after Melvin Edward Conway, a little bit old, says that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. So we have 3 teams and we have 3 systems. It is to mention that it is very important that we don't look at the people and the systems, but at the edges between them. Communication structures, not the people and not the systems. Important too, but with this. Okay, domain-driven design, what is it? Domain-driven design was founded by Eric Evans in, I think, 1992, and is a design principle for software architectures. First of all, what is a domain? A domain is everything of your company, your business, your organization, your corporation. Papers, systems, data, minds, people, processes, everything. We can divide organization or a domain into subdomains. And Eric Evans, in his book, divided these subdomains into 3 categories: core domains, supporting domains, and generic domains. core domains are these domains that your organization makes your organization, your business processes, your why you do your corporation and or your organizations. Supporting domains are, for example, supporting processes. Which do you need to fulfill your corporation designs and targets? And generic domains are, for example, accounting or project planning. Stuff you don't develop your own project planning software, you just buy it like Jira or something. Okay. And how do we use these subdomains to design our system in our corporation? How to produce software with it? First of all, each subdomain can be shown as an organizational unit, for example. Teams, organization units, and so on. And on top of it, we have these bounded contexts. There's another principle. So we have a subdomain, and on top, we're building a bounding context. What is a bounding context? When we declare the subdomain as a problem space, the bounded context is a solution space. The bounded context is this part of your subdomain that you want to model and make software on it. It can be a process, it can be formulas and forms and so on, and also data. You can decide a rule that a bounded context only describes a subdomain. Sometimes you have a bounded context here, like here, over the borders. That's not the ideal world, but yeah, the reality sometimes. And you want to put one team on one bounded context. So here comes in mind we have a decentralized and related organization unit on our bounded context. So bounded context is a solution space for a subdomain. We have one team that develops in a bounded context. A bounded context is not the whole subdomain, but only the parts needed to fulfill our targets. Now a more concrete part, the model in a bounded context. What is a model? Model are data models, processes, software code, services, descriptors, CI/CD systems, and so on. And each bounded context now encapsulates its own domain-related model and owns them. We have data ownership in this point. These models are the main data structure of the subdomains. For example, we have customer creation or a registration process. So we have a registration bounded context where all the registration processes and the customer creation and the customer IDs are generated in this bounded context. There is a data ownership. On another part, we may have a contract bounded context which relates to a customer, but the contract itself owns these bounded contexts. The contract ID is generated in this bound context, data ownership. When you read about domain-driven design, you will come to a phrase is called ubiquitous language. And these, just to be complete, what is a ubiquitous language? If we are in this model here, we speak of a customer that is, may look like this ones here, like with an ID, a name, surname, email, and address. In another bounded context, a customer may look like completely different or has another name. For example, newsfeed target with a name, a surname, and email address, or delivery with a first name, last name, and delivery address. These are related parts to the main or the data owner customer bounded context in this part. Okay, so what do we have? We have bounded context with different data ownerships, and now we want to interact with this bounded context. A customer has to be a contract wants to interact with a customer, for example. And a domain-driven design defines for this purpose domain events and commands. It's, I think, a little bit easy. Events are passive, so something occurs in my bounded context here, decide what you want to do with it. Or commands, me as a bounded context wants you to do something. For example, a customer registers in the bounded context of customer, and this bounded context sends a command to the contract bounded customer, create a contract for this customer. Or, in a more passive way, the customer is created, we have a customer created event, and the contract bounded context decides, a new customer. Maybe I create a contract for it. So, do not mix it up with synchronous or asynchronous communications on a technical level. This is only business or domain related in this part. Do I have a passive event or an active command? Okay. Summary. It's much theoretical now, but we have to have this ground. A bounded context is now a logical and technical encapsulation area which describes a subdomain. We have a software system which describes our subdomain. Contract, customer, processes, billing, and so on. One team owns a bounded context and develops it. Develops, in this case, might not be software development, but also software integration, which I bought, for example. The team is interdisciplinary, so we have not only software developers, but also domain experts, QA experts, and so on. And yesterday we heard about data meshes. So we want to have even data engineers in our teams, which are encapsulated in the subdomain. Communication between bounded contexts occurs via domain events or commands. So, and what is more important, never fix. A subdomain or bounded context can change over time, and I have, all the time I have a look on it if it's still right. Okay, so now we are at a point where our organization describes subdomains and on top of it, bounded context. For example, we have an old monolith. We have a bought ERP system. And on the left side, we have two individual software products, which we develop and which, for example, describes our company. And a most important part of it, how, and now back to Conway's law, how the communication structures are between these bounded contexts. So we have some edges here, and domain-driven design describes some communication patterns between them. I don't think that we take every one of it, but for example, customer-supplier relations. So me as a customer has a relation to the contracts. A contract might be have a relation to billing. Customer supplier is defined as upstream and downstream. So maybe I have a team and another team, and I communicate with them. We need some APIs, we need some data formats. What do you need? What can I offer? And so on and so far. Another important part is the conformist pattern, especially when I have a board system. I cannot change an API or fairly, I cannot change the API of a board ERP system. I have to take what it is. So I have a conformist pattern. There is no communication in this manner. There are other patterns when you read about domain-driven design, and it's really interesting. For example, open source service or published language, when you offer an API to your customer, for example. Some specials are separate ways. When I build my own system instead of using another system, and mostly in old legacy systems, I have this big ball of mud. I think you know about it. It is not a design pattern, but often a current landscape. So that leads me to legacy systems or current systems that I have in my corporation, because all what I told you about bounded context and the subdomains, that is mostly greenfield projects. So I will start at zero and grow up. But mostly I have current systems or board systems. And often these current systems are domain and technical related and also separated. For example, service-oriented architecture or ESBs and so on. These are also separated. They have service, make the service mesh. But we also have service bulks with, I call it a central brightness into our system. If you are in a big corporation, you have this stuff like user services or engines and so on. Really big software blocks which are centralized, and you cannot develop around it. You have to use it. Okay, so we have our organization. We designed our subdomains and our bounded contexts. And there are two ways to do it. There are, I think, three, but two main. First of all, organizational driven. So I have a look on my company. I have my organization parts like customer, contract, billing, big data, stuff, and so on. And I take these communication structures and define my systems on it. So I use Conway's law with domain-driven design, define my bounded context, my subdomains, and building my systems. For example, I have an ERP team, so this ERP team buys an ERP system and use it. I have two teams which develop their own stuff, so I have two systems which are developed individually. Another approach is system-driven. One back. Yeah. This fits also good in a greenfield a project where I start from zero and grew up a new corporation. System-driven fits good in a brownfield scenario where I have existing systems and organizational structures, like an SAP system or an old monolith. Then I can have a look on it and think, okay, this is my SAP system, and there is some system which uses and extend my SAP system. I have one team that manages this one. So I have my bounded context, and therefore they're my subdomain. Okay, I have a match. Another one is I have an old monolith, and I have two teams which manage this monolith. It's not ideal, but it's the current system. So what is most important here is further changes in the system and the organization landscape is necessary. Maybe I use my old monolith and merge my teams. Or my teams are as it is, and I have to split my monoliths to have a clean architecture in here. These are brownfield stuff. Okay. Now this is domain-driven design, which leads us to a decentralized, domain-related design and architecture. And how can we produce from this a real technical architecture? And there comes the self-contained systems, which are a good system architecture to fulfill my needs of domain-driven design. What is a self-contained system? A self-contained system is developed by one team. A self-contained system describes a bounded context and the domain-related technical stuff in it. A self-contained system may be one service or n microservices if you want to. A self-contained system has its own UI, its own use services, and its own persistence. What does it mean? If you have a look at, for example, Amazon, the product page is one bounded context. If you go to your personal personal data, a whole new context switch is made. The page has a full page request, builds up, and this is a bounded context switch or a self-contained system switch. Inside a self-contained system, I have my own UI and jump here and there. And on a context switch, I switch also the whole page. So I have a split in my persistence, in my service layers, and also in my UI. Each self-contained system has its own domain model because it builds up a bounded context and its own ubiquitous language. So a customer looks here other than maybe here. The communication between self-contained systems should be asynchronous. Why? I can tell you later. This is an example of a self-contained system. So we have one team, we have our border, the bounded context, and 3 services in it. We may have synchronous communication inside our bounded context. And for the outer world, and this is important, this bounded context is a black box. I have not to know that there are 3 services which communicate synchronous with another. Or they use different databases or schemas or one central database. Because my self-contained system communicates with the outer world with domain events and domain commands. For example, I can use Apache Kafka for it as event bus. And if I have other bounded contexts which are interested in my data for my first bounded context or my first self-contained system, they can just consume these events. So I have my customer, he registered. An event occurs, customer created, and all my bounded contexts which are interested in customer data just consume these events. The bounded context here, or the self-contained system, is still a black box. They just communicate with domain events and domain commands. Okay. Pop, 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 pop. Yeah. Now to some examples of the real world, because this was a theory, now to practical. One project of us was in the e-com scenario for a big German retailer. And they take a third way. They made a user journey domains or user journey related subdomains. So they bought one e-com system as monolith, and they have a look how is our user journey. We have a landing page, we have some product information, we have a search, we have orders and fulfillment in the end. It's a third approach. Yeah. Because when I look at my current organization and decide to use a new technique like user journeys, for example, I maybe have not only changes in my system, but changes in my organization and in my system landscape. It's a little bit harder, but worthwhile. So what we did there, we begin to split this monolith structure and this big database into separate services. We begin with a landing page and so on. And after 5 years, the monolith was shut down. And we had 5 big self-contained systems and therefore bounded context with a central Kafka event bus. And in it, domain-related topics. These are only examples. It's for the much more, I think, 30 or 40 topics. So each bounded context produces domain events, which are state data of changes which are made there. All domain events and commands will on the service bus or event bus, because Apache Kafka has a big advantage. You can configure it to prevent all events which even ever occurred on this bus and persisted. So a consumer has a completely history of all events which occurs, for example, in the customer topic. It's a big advantage because you can just put another bounded context, for example, big data, on top of it and consume the complete history of all events there. So what is the advantage of it? You can add a new consumer, fully transparent for the old stuff there. And these new consumers just consume the domain events which occurs. The domain events is the truth. A big data do not need access of details of this bounded context here. It just has everything it needs here on the event bus. The event bus itself can be, for example, a JSON format. Each event is a JSON format. So you have a homogeneous data format. You can design each event with an ID, a timestamp, a version, or so on. You can, for example, they did consume everything in the big data, but you can also separate it. For example, you just need customer and orders and just combine these ones and make predictions on it. Another project which is currently on is an energy provider, a German energy provider, and they have a 30-year-old application which runs on an IBM i-series mainframe, really old stuff. And this monolith is one big bounded context, and they have one big subdomain or domain. And the difficult is now to split teams and the whole system in it. And for example, we begin with customer information and try to separate this code from the monolith. This one here is organizational driven, so they do not want to make change in the organization, but only in the system. The organizational structure is more or less okay, and time will show if it is a good part, because, for example, this subdomain or bounded context here is much too big. These are, I think, 30 people or so. It's too big for one development team. Somewhere we have to make another split in it. So there, a bounded context is never, or not for others. A bounded context is never fixed. So it has to change over time because the organization has changed. Next step here is the introduction of Apache Kafka and to separate the next steps. It's not easy. This project here is planned for the next 7 or 8 years, I think. It's a big deal. Okay, now 10 minutes left. I'm at the end. What did I want you to show with domain-driven design? Or domain-driven design offers us tools and procedures to analyze existing or planned system landscapes. We can use bounded context on top of subdomains to have a technical and domain-related encapsulation. We can use ubiquitous language as a language inside our bounded context, which is their fit. Think of a customer in a contract-based manner or a customer in a billing-based manner. It's completely different on much parts. We can communicate on each between bounded contexts with domain events and commands. We can use synchronous or asynchronous communication patterns. Asynchronous has more advantages. And with self-contained system, we have an architecture approach which fits very good to domain-driven design. A self-contained system implements a bounded context, and we have one team as bounded context. And their communication between self-contained systems occurs, for example, with Apache Kafka, which we use because it has this advantage of event storing or event persistence. Okay, some tips for literature. I do not get money for this, but it's a good book of Ron Vernon, Implementing Domain-Driven Design. And some good pages from Martin Fowler about bounded context. And InnoQ, it's a company, I think, in Düsseldorf in Germany, which has a good page about self-contained system, how they work, which advantages and disadvantages they have. And then, then I have to thank you. Be patient. This was my first talk in English. Okay. If you want to stay in contact with me, email, Twitter, GitHub, LinkedIn, and the slides.
Any questions? Okay.
Thank you. Thank you for the presentation. I was curious if you can share with us some tips on how to start discovering the domains and bounded context. You mentioned some tools and procedures. Can you share some examples?
Yeah. I did show you, I think I can, it's okay. I showed two steps, an organizational approach or a system approach. So first of all, have a look, for example, at your complete organization. What parts and departments are in it, and make a map of it. Sales, customers, contracts, billing, whatever you have, and try to make communication relation between them. This is one approach. Another approach is have a look at your system landscape. Where are system blocks? Where are monoliths? Where are microservices? Can I combine microservices, for example, to a domain blob, I think? Or what does my monolith? Does he only contract stuff or contract billing, registration, everything, for example? And you can identify these domain-related things. But it is nothing which you do one time. It is also a communication process. And I would suggest to start with an organizational landscape, because it's easier than to have make a sort of splitting monolith structures or so.
Thank you.
When is a bounded context too big? In here.
Yeah.
As you mentioned that sometimes a bounded context can be too big.
Can you repeat it? Sorry.
How do you decide that a bounded context is too big and it needs to be split in multiple ones?
First of all, if my team is bigger than 8-9 people, it might be a good sign that my bounded context is too big. Or if I have different processes in it, or different it's more a feeling, I think. Different domain processes in it. This might be a sign that my bounded context spans 2 subdomains, for example. Then it's also too big. But this is more difficult than team size.
Anybody else? Any questions? Yes, that being said, I think we could do the same like we heard. Right, yeah. Thank you.
Thank you.